I met a man whose perspective I respected and whose work greatly affected me. I asked him if he'd give me just a bit of his time, tell me how he ended up with the success in his life. And he smiled at me and he said, son, it's easy. He said, what you see is what you get, and what you think is what is set. Envision it and it will be. So everybody keep moving, staying positive and rolling on. Keep on looking for solutions, and one will welcome you with open arms. Everybody keep moving, facing challenges will make you strong. Look for positive solutions. Love is living with an open heart.
We've done a lot of factoring, but we've only typically seen binomials and trinomials. We've looked at taking GCFs out. We've looked at guess and checking by opening up two binomials. But what do we do when we have four terms? So right now, remember, terms are separated by addition and subtraction. So I have this term, I have this term, I have this term, and I have this term. And there's not a common factor in all four terms. So what I'm going to do is I'm going to do something called factor by grouping. And I'm going to group these two together. And I'm going to group these two together. And in this first group, I can see they have a GCF of 4 and an x squared. So I'm going to take out that 4x squared. And I'm going to be left with x minus 1. And in the second group, I can see they have a GCF of 9. And I'm always going to take out that negative. That whatever this sign is, I'm going to take that sign out. So I'm going to take a negative 9, and I'm going to be left with x minus 1. The key to factor by grouping is that the groups match. Those must match, okay? So if you look at this, I have one term, and I have two terms, okay? This whole thing is one term, and this whole thing is another term, and they both have a common factor of x minus 1. So the first thing I do is I write down my common factor. Then you can see if I take this out of this one and this out of this one, I'm left with 4x squared minus 9. If I were to multiply these two binomials out, I would be returned right back here. But when we factor, we're always trying to get to an exponent of 1. And notice I have an exponent of 2 right here. And if I look at this, I can see that this isn't done being factored. This is actually the difference of squares. So the x minus 1 is going to stay. This will be the difference of squares. And 4x squared is 2x times 2x. 9 is 3 times 3. And remember, if I want to get rid of this middle term right in here, I need 1 to be plus and 1 to be minus. And remember, these two things are called conjugates of each other. Now, if I were to multiply this by this, and then take that answer and multiply it by this, I would be returned right back here. That was the song named Solutions by a band called Euphorchestra. Want to make sure that you understand going into this unit that once again, when we solve a function or a graph, solutions are x-intercepts. One of the ways we find x-intercepts is by factoring. This first one is 4 terms, so the first thing we're going to do is group it right here in the middle. And I'm going to go ahead and let you guys group that to the first step. So you should have all been able to get to this step. I know I'm not giving you much time, but this is factoring and we've been doing it for quite a while. Now that we're doing polynomials, notice that we've been working with things other than squareds. This is cubed, this is to the 6th. So I have always said that you are not done factoring until your x is to the 1st or it's infactorable. So I need to look at everything that does not have an x to the 1st. Remember, this is an x to the 1st. So this binomial right here is not factorable anymore. It's down to its prime. But I need to look at this and I notice this is the difference of squares. So I know that will factor further. So this becomes x plus 5. The difference of squares is x plus 3, x minus 3. That is fully factored. I believe on your paper this is set equal to 0, which means I want to solve this. So I'm going to take each of these factors out and set them equal to 0. That's going to give me -5. I'm going to set this one equal to 0. That gives me a -3. And I'm going to set this one equal to 0. And that gives me a +3. I want you to start noticing something. I have an exponent of 3, and I have 3 places it crosses the x-axis. Not always will that work, but it will have 3 solutions. That will have 3 solutions, real or imaginary. This guy over here will have 6 solutions, real or imaginary. So again, I'd like you to group this first one right now and get to the first step. So you should have been able to factor to this point. But notice, I am not down to an exponent of 1, so I have to look at both of these binomials and ask if I can factor them. This again is the difference of squares. This is not the difference of squares, so this binomial, even though it's to the power of 2, is done factoring. This one, though, can factor more. So this one says y squared minus 3. This one can become y squared plus 4, y squared minus 4. And again, I have to ask myself this question. We know this can't factor. This is the sum of squares. That can't factor. But this is the difference of squares. So this can factor again. So the first one stays. The second one stays. This becomes y plus 2, y minus 2. And now we're going to solve because I believe this one also says solve. So I'm going to set each of these equal to 0. I'm going to add 3 and take a square root. I'm going to set this one equal to 0. Subtract 4, take a square root. Remember, a negative square root comes out as I, and I'm going to put a 2 in there. Set this one equal to 0, and I'm going to get -2. Set this one equal to 0, I'm going to get +2. So let's count up our solutions. We're supposed to have 6. I have 1, 2, plus 2i is 3, minus 2i is 4, plus root 3 is 5, minus root 3 is 6. These guys right here are imaginary, so we won't see them cross the x-axis. So I will cross the x-axis at plus radical 3, minus radical 3, -2, and +2. And 2 of my solutions will be imaginary. So we know in solving that I have to set the polynomial equal to 0, so I'm going to subtract that 8x to the 4th over, and I'm set equal to 0. The only thing I have in here is a GCF of x to the 4th, so I'm going to factor out the x to the 4th. That would leave me x cubed minus 8. Now, this brings up a point, so I need you to turn over to the back of this paper where you have a blank side, and on the bottom, or on the top of it, I want you to write difference of cubes and sum of cubes. We're going to learn how to factor what's called the sum of cubes and the difference of cubes. Right now I have a binomial that is 2 things subtracting, so the subtraction stands for difference. This is a cube, x times x times x. This is a cube, 2 times 2 times 2. 2 cubed gives me 8, x cubed gives me x cubed. So I'm going to have to factor this using these formulas. So first thing I'm going to do is mark it. When you're finding the sum and differences of cubes, you need to find an A and a B. And we're going to do the difference of cubes first. And the a is what number cubed gives me my first term. Well, that's pretty easy. X cubed gives me my first term, so x will be a. This b is going to stand for what number cubed will give me the second term. So I know that 2 cubed gives me 8, so 2 will be my b. And I factor like this. I factor a minus b, a squared, plus a times b, plus b squared. So I'm going to use my a and b. A minus b, a squared, plus a times b, plus b squared. And that's the difference of cubes. So while it's on our mind, we're going to come back up here to the paper, and we're going to change that to what we just factored. A minus b, a squared, plus a times b, plus b squared. All right, go back to the back, and we're write down this example. We're going to do 27x cubed plus 64. And again, we're looking for an a and a b. I know that these are this is the sum of cubes. These are both cubes. So how do I know if 27 is a perfect cube? Go into your calculator under math. Number 4, I believe, is cube root. Type in cube root, put in the 27, and it will tell you that 3 is the cube root of 27. So 3x times 3x times 3x will give me my first term. Do the same thing for 64, and we will get 4. The sum of cubes works the same. The formula is just a tad bit different because of the signs. So the sum of cubes, instead of having a minus b like I do over here, I have a plus b for the sum of cubes. Then this sign changes to a negative when this sign changes to a positive. And the last one's always negative. So now using my own a and b, I have a plus b, so 3x plus 4. A squared is 3x times 3x. A times b minus 12x plus b squared. That is the sum of cubes, and we will be practicing that. So going back to the top, if I wanted to solve these, and this is the last one I'm going to solve just for the purpose of it, but I'm going to set this equal to 0, this equal to 0, and I'm going to get 2. And I'm going to set this equal to 0. The problem is that will not factor. So it's a quadratic, and because it's a quadratic, the only way I can figure out what the solutions are, besides completing the square, is using the quadratic formula. So I'm going to use the quadratic formula to find the solutions. I'd like you to pause the computer and copy that down. So just to walk you through this, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 4 minus 16 is negative 12. Don't forget that with a negative underneath, it comes out as an I. If I simplify root 12, it's going to be 2 root 3. If I can cancel a 2 in both terms, then I can simplify it to this. So real quick, I'm supposed to have 7. I have 2 here, negative 1 plus I root 3, negative 1 minus I root 3. I have a 2 here, that's 3. And this 4 counts for 4. And the one thing I want you to write down here is a note. And even in this situation will be a bounce. Just like a double root, we will have a bounce. So at 0, this guy will hit and go up, one way or another. I don't know if it's up or down right now. Okay, let's do number 4. I'm going to add that 6. And I have a trinomial. So Now, if you notice, we have already factored things like this. So if it's a trinomial, I can open up two binomials. I know that x to the fourth is going to be x squared times x squared. And now remember from guessing checking that I need this number times this number to give me positive 6, but the inside and the outside to add to negative 5. So both of my signs have to be negative, and that's going to give me a 3 and a 2. And if I were to check real quick right here, this would be minus 3x squared minus 2x squared, which is minus 5x squared. So I checked it. So now I'm just going to take each binomial, set it equal to 0. So x is going to be plus or minus the square root of 3. And I'm also going to take this binomial and set it equal to 0. And take a square root, and x is going to be plus or minus the square root of 2. And again, just to reiterate, I can see right there that I'm going to have 4 solutions. Just like over here, I had 7 solutions. They could be imaginary, they could not be imaginary. But I'm going to have 4 solutions here. Here's 1, here's 2, here's 3, here's 4. So for the rest of this video, even though these, I believe on your worksheet, have been changed to zeros so that we would solve, for the purpose of time, I'm just going to factor. So I'm not going to solve them, I'm just going to factor. This is the sum of cubes. So if you remember from the sum of cubes, we have to find an A and a B. And I know that x times x times x will give me my first term, and 2 times 2 times 2 will give me my second term. And the formula is, again, for the sum of cubes is a plus b, a squared minus ab plus b squared. So I get x plus 2, x squared minus 2x plus 4. I know one of my solutions here would be negative 2. This I would have to put in quadratic formula. Going to D, this is the difference of cubes. So again, I need an A and a B. How do I know this is a difference of cubes so quickly? It's because of that exponent right there. It's a cube. It's not a quadratic, so I can't factor it like a quadratic. I need to factor it like a cube. So again, s times s times s will give me s cubed, and 4 times 4 times 4 will give me 64. So my formula for difference of cubes, because I have a subtraction sign here, will be a minus b, a squared plus ab plus b squared. And I really don't like using s's because it looks like a 5, but we'll go for it. S minus 4, s squared plus a times b plus b squared. That's factored. Solving, this is going to give me a solution at 4, if I want to write it as an ordered pair. This I'm going to have to do quadratic formula. Oh yay, another sum of cubes. How do I know? Because that's a cube and that's a plus, so it's a sum. If I put the cube root of 27 in, I find out that A is going to be 3x times 3x times 3x gives me 27x cubed. 5 times 5 times 5 gives me 125, so B is going to be 5. So you already have the formula. It's going to be A plus B, since it's the sum of cubes, A squared minus A times B plus B squared. I'm going to set this one equal to 0. I'm going to subtract 5 and divide by negative 3. So my first solution will be negative 5 over 3, 0. This one I'm going to have to put into quadratic formula and solve it out. All right, let's go to the last example. I can see that they have a GCF, so I need to factor the GCF out first. They all have an x squared I can factor out, and they all have a 7. So the first thing I'm going to do is factor out a 7x squared, and that's going to leave me 4x squared minus x plus 2. And now this 7x squared is just going to come down here to the bottom, and I'm going to deal with this guy in here. I'm going to multiply 4 times 2, and I'm going to put 8 over x in my calculator. I'm looking for the pair that will multiply to 8 but give me negative 1. I do not believe there is such a pair. So, how do I solve this? I solve this by doing the quadratic formula. That means that is done factoring. So if I'm factoring, this would be my final answer. But what if I wanted to solve? I would set this first one equal to 0, and I know x is going to have to equal 0. 7 times 0 is going to give me 0. But because of this, I know this is going to be a double root, like we did in the last unit. This guy right here I'm going to have to do by the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be negative 1 plus or minus the square root of negative 31. Sorry, this should be a 2. All over 8. I need to look at my square root and see if I can simplify it, and I know that negative has to come out in front of the radical as an I. So I'm going to have x equals negative 1 plus or minus I root 31 all over 8. And this can't simplify anymore. So the question, how many times will this quartic, right, degree 4, how many times will this quartic touch the x-axis? Think about that for a minute. In my quadratic, I get negative 1 plus I 31 over 8 and negative 1 minus I root 31 over 8. There are 2 solutions right here. I know because of the squared, I actually have to count 0 as twice. So there are 2 solutions here and 2 solutions here for a total of 4, just like it says up here. How many times will it actually touch? These over here are imaginary. We know they don't touch. This here is a double root, which means it's going to touch 0 and bounce back up. So it will actually only touch 1 time physically on the x-axis. Okay, now I just need you to complete the entrance ticket on the bottom of your notes, and we shall see you at class.